Dear students, today we will discuss some theory topics of the transformer like equivalent diagram of actual transformer. You see, this is the primary where we are given a supply V1. This is the primary winding, this is the secondary winding. As whenever we are talking about the practical transformer, in that case we will have the primary winding resistance as R1 and primary reactance as X1, secondary resistance is R2 and secondary reactance is X2, and this is the terminal voltage V2. And this load may be a resistive load, may be inductive load, may be capacitive load. Now the issue is that whenever you are going to draw the phasor diagram, then there is a problem. Now how will you start the phasor diagram? Now you see the resistive drop across the this R1 is I1 R1, and the reactive drop across this reactance is I1 X1. So we have the impedance Z1 equals to R1 plus JX1. Here also Z2 equals to R2 plus JX2. Now you see, if we have the voltage equation that V1, if we apply KVL here, so V1 equals minus I1 R1 minus JI1 X1 equals to, you see, minus E1, because we know the induced EMF across the primary winding is nothing but is opposing the supply voltage. That's why this difference is equals to minus E1. If there is no load, that means no load means it is ideal condition and resistive drop, reactive drop are not there. In that case, V1 will be equals to minus E1. So here V1 minus I1 R1 minus JI1 X1 equals to minus E1. Now you see, so automatically V1 will be equals to minus E1 plus I1 R1 plus JI1 X1. Similarly, in the secondary side, the induced EMF is E2, and this will act as a supply to the secondary side. So if E2 becomes a supply, then the drop across this resistance, the drop across this reactance, and the drop across this load, this total drop here will be equals to E2. So nothing but E2 will be equals to R2I2 plus JI2X2 plus V2. So now we'll come to the phasor diagram. Then how will you draw the phasor diagram? Say this is the diagram for purely resistive circuit. So purely resistive load. This load is purely resistive. So if I consider a load is purely resistive, in that case, now you see, we know that this current I2, the I2 secondary current I2 and V2, they will be in same phase if this load is purely resistive. Now as the basic diagram of a transformer phasor diagram, see this phi, the flux which is passing through the core, you take it as reference, and we know that the induced EMF E1 and E2 are lagging behind this phi by at an angle 90 degree. So first you draw this thing, E1 you draw, so phi you have drawn, and then you draw E1 is lagging 90 degree. Clear? Now what you do? You have to draw V2 and I2. As you know that this E2 will be equals to R2I2 plus GI2X2 plus V2. So you take one assumption, the V2, and you draw I2. So and V2 and I2 will be in same phase. Now E2 is equals to what? V2 plus I2 R2. Now this is what I2 R2. I2 R2 is a resistive drop which will be same phase with I2. So it will be overlap. So from the tip of this V2 you draw I2 R2, this length. You draw this length. So it is I2 R2. Then we have plus JI2 X2, the reactive drop. When it is plus J, it will be become 90 degree. So I2 X2. So this V2 plus I2 R2 plus Gi2 x2 is nothing but E2. Now, as we know that the additional current which is required, that is I1 dash at the primary side, say when the secondary side is loaded, in that case the additional current is required to supply in the secondary, so the primary current automatically increase. So this I1 dash will be is nothing but N2 by N1 into I2. So there is a fraction, right? If N2 is greater than N1, then automatically I1 dash is bigger than I2. So let N2 is greater than N1. So in that case, you see, if it is this length is I2, so in the 180 degree phase opposition we have I1 dash. Now this parallelogram of I1 dash and the no load current, it is nothing but I1. Now what we know, what is V1? V1 equals to minus E1 plus I1 R1 plus Ji1 x1. Now if you want to draw minus E1, now this is E1, this length is E1, so in the opposite side you take minus E1 here. Here you take minus E1, this portion is minus E1 in the 180 degree opposition. So from the tip of minus E1 you draw I1 R1, this resistive drop in the primary. It should be same phase with I1, so this will be parallel, so I1 R1, and then you draw plus Ji1 x1, so it is 90 degree again, so plus I1 x1 here up to this, so the summation of these three will be V1. So by this way you have to draw the overall phasor diagram. Likewise you can draw the phasor diagram for inductive circuit and for capacitive circuit. For inductive circuit, the terminal the secondary current I2 will lag behind V2 by some angle, and for capacitive circuit, that is resistive capacitive, the secondary current I2 will lead V2 by some angle, and accordingly you have to draw the phasor diagram. Thank you.